Hello, everyone. Have you ever wondered about the invisible shield that protects our planet? It's our Earth's magnetic field, and it's quite a fascinating thing. Recently, there's been a lot of buzz about a hole in this field, particularly in a region called the South Atlantic Anomaly. Now, before you imagine a literal hole, think of it more like a dip or a weaker spot. This anomaly, largely over the South Atlantic, but also touching parts of South America, has been known since the late 1950s. Scientists noticed that the Van Allen radiation belts, which are donut-shaped zones of energetic particles trapped by our magnetic field, dip closer to Earth's surface in this area. These belts are usually quite high up, starting over 600 kilometers away. Why is this important? Well, when these radiation belts come closer, satellites and even the International Space Station can be exposed to higher levels of radiation. This can interfere with sensitive electronics and, of course, affect astronauts. It's worth noting that this doesn't impact airplanes because they fly at much lower altitudes. What's new is that this anomaly seems to be changing, even splitting into two distinct patches. NASA, using data from various satellite missions, has been tracking this. They've observed that the anomaly is weakening in its center, with one part remaining over South America and another drifting southwest towards Africa. Some studies even suggest this anomaly might be affecting the aurora in the southern hemisphere. This naturally leads to a big question. Could this be a sign that Earth's magnetic field is about to flip? Geologists tell us that Earth's magnetic poles have reversed many times in the past, roughly every 450,000 years. While this might sound like a long time, for geologists, it's relatively frequent. A flip could potentially weaken our planet's shield against cosmic radiation for a significant period. However, the current scientific consensus is that the changes we're seeing in the South Atlantic anomaly are not an indication of an imminent magnetic field reversal. The leading idea is that this anomaly is caused by the complex movements of molten iron in Earth's outer core, which locally weakens the magnetic field lines emerging at the surface. Models suggest this anomaly has been a feature of the outer core for millions of years and is likely a localized phenomenon, not directly linked to a global flip. Still, studying this anomaly is incredibly valuable. It gives us a unique window into what's happening deep inside our planet, which could help us make better predictions about future magnetic field behavior. It's also a powerful reminder of how fortunate we are to have this natural shield protecting us from the harshness of space. Think about Mars, which lost most of its magnetic field billions of years ago. This is why its surface is bombarded with radiation, and it's likely why it lost its atmosphere to the solar wind. Science is all about understanding our world and solving complex problems, and that's exactly what Brilliant aims to do. They make learning science, computer science, and math incredibly engaging and accessible through interactive visualizations and real-world examples. Whether you're curious about data science, quantum mechanics, or anything in between, Brilliant has courses designed to spark your curiosity. I even have my own course on quantum mechanics there, which breaks down concepts like wave functions and entanglement. And for you, my wonderful viewers, I have a special offer. Visit brilliant.org/Saina or scan the QR code to get a full 30-day free trial of everything Brilliant has to offer, plus a 20% discount on an annual premium subscription. It's a fantastic way to explore and learn. Thank you so much for joining me today. I hope this exploration of Earth's magnetic field has been as fascinating for you as it is for me. If you enjoyed this, please consider following or subscribing for more insights into our amazing world.